The length of a shadow. Suppose that the angle of elevation of the sun is 23.4 degrees. Find the length of the shadow cast by a person who is 5.75 feet tall. All right, so relating shadows to the height of the object casting the shadow is pretty interesting. So now, if you're like me, you might be wondering, well, how would you know the angle of elevation of the sun, right? Well, what you can think about is potentially, I'm not an expert in this, but maybe there's like tables that you can do a Google search on this, and there's tables that would give the angle of elevation of the sun, like at every, down to the minute of the day. And how would they determine this? Well, they get an object of known height, and then they measure, right here, we're trying to find the length of the shadow, but, you could easily measure the length of the shadow, of the shadow that the sun is making. And so then with that, you could calculate the angle of elevation with trigonometry. Okay, so how do you do this? Well, the idea is that these are similar triangles. This right triangle here and the larger right triangle are similar triangles. Well, actually, I didn't even need to state that they were similar triangles, because obviously this angle is the angle of this triangle is the exact same as the angle of the larger triangle. So, but there's something to note that these are similar triangles. So these two angles would be the same. But so what we're going to do is we're going to say that the tangent, we'll call this x, the tangent of 23.4 degrees is equal to opposite over adjacent. So cross multiply. Now divide by the tangent of 23.4, both sides. So the length of the shadow is approximately 5.75 divided by tangent. We're in degree mode, 23.4. So we're not worried about significant digits or anything. We're not focusing on that. So we'll just put 13.3 feet.